Good morning everyone. So today we will discuss about testing the difference between two means of dependent samples. So first, let's define what is dependent samples. So in dependent samples, each member of a sample is related to a member of another sample. So dependent sample, also called a paired t-test. So it is used to compare the means of two related groups to determine if there is a statistical significant difference. So here's the formula in finding the dependent samples. So T, or the standard test statistic mean, is equal to the mean of the difference of the paired entries minus the hypothesized mean of the differences of the paired entries of the population all over the standard deviation of the differences of the paired entries in the samples divided by the square root of sample size. Here is the formula in finding the d-bar and the standard deviation. So let's proceed to our example. So the example table include 8 persons with 2 different scores. First, we need to find the value of D. So we simply subtract the after result from before. So 81 minus 77 is equal to 4. 73 minus 71 is equal to 2. 77 minus 71 is equal to 6. 64 minus 68 is equal to negative 4. Then 76 minus 70 is equal to 6. 84 minus 77 is equal to 7. And 59 minus 59 is equal to 0. 71 and minus 74 is equal to negative 3. So after getting the value of D, all you need to do is to add all the value of D to get the summation of D. After getting the sum of D, we can now find the difference between paired entries. So the formula in computing the difference between paired entries is D is equal to the sum of D over N, which is the N is the sample size. So substitute the sum of D to the formula, which is 18, divided by the N, which is the number of sample, is equal to 8. So 18 divided by 8 is equal to 2.25. So the value of D bar is equal to 2.25. After getting the value of D bar, next, we need to find the standard deviation. So to find the standard deviation, we will square the value of D na nakuha natin kanina, which is the 4, 2, 6, negative 4, 6, 7, 0, and negative 3. So we will square it one by one, which is 4 squared is equal to 16, 2 squared is equal to 4, 6 squared is equal to 36, negative 4 squared is equal to 16, 6 squared is equal to 36, 7 squared is equal to 49, then negative 3 squared is equal to 9. After getting the square of every D value, you will add all the value to get the sum of D squared. So the sum of D squared is equal to 166. So after getting the sum of D squared, we can now compute the standard deviation. So the formula in finding the standard deviation is the square root of the value of the sum of D squared minus the sum of D raised to 2 divided by N all over N minus 1, where N is the number or the sample size. So let's substitute the value. So the sum of D squared is 166 minus the sum of D, which is 18 raised to 2 divided by N, which is 8, divided by N minus 1, which is 8 minus 1. So our standard deviation is 4.234. Now that we have the value of D bar and the SD, or the standard deviation, we can now compute the standard test statistic. Assuming that the hypothesis mean is equal to 0. Now, let's substitute the value of d bar, which is 2.25 minus 0, all over the value of standard deviation, which is 4.234 divided by the square root of n, which is 8. So, the value of t is equal to 1.503. That's all for today's discussion. I hope you understand our lesson. Thank you for listening.